Welcome, dear students. Now we discuss Unit 1 2023 Advanced Mechanics Semester 6 Solutions. Question paper 23, Unit 1, Group B. Question 2A. Define generalized coordinates and a scleronomic system. Find the expression for the kinetic energy of system of n particles and show that for a sclerodermous system, the kinetic energy is homogeneous function of generalized velocities. The solution of Unit 1 2023 answer these generalized coordinates. The minimum number of independent coordinates required to completely specify the configuration state of the dynamical system at any given time is called the generalized coordinate of the system. And scleronomic system constants are said to be scleronomic if the corresponding constant equations do not explicitly contain time t. A scleronomic system is one which has only scleronomic constants. Example, a pendulum with fixed support with an inextensible string of L of length L such that x square plus y square equal to L square. As the constant equation is independent of time t, it is a scleronomic. Second part, find the expression for the kinetic energy of a system of n particles and show that the sclerodermous system, the kinetic energy is homogeneous function of generalized velocities. Consider a system of n particles. The transformation equation for the position vectors of the particles are Ri vector equal to Ri vector is functions of q1, q2, qn and t, where t is the time and qk, that is k runs from 1 to n, small n, are generalized coordinates. Differentiating 1 with respect to t, we get the velocity of the ith particle. Derivative of Ri vector equals to summation over j equal to 1 to small n del qj Ri vector into del t qj plus del t Ri vector. Therefore, this equals to vi vector, that is Ri dot vector, equal to summation over j equal to 1 to small n del qj Ri vector qj dot, this ddt qj dot, plus del t Ri vector. Equation 2. Then the kinetic energy T equal to summation I equal to 1 to capital N, number of particles, half into mi into vi square. So vi is the half mi summation half mi Ri dot square. Now this half summation half mi bracket Ri dot is this from the expression 2. So put this Ri dot from 2 by 2, and this dot means vector dots this dot this. So multiply this dot product. So some half summation over I equal to 1 to capital N, and note that here j runs equal to 1 to small n, and k equal to 1 to small n, del Ri vector del qj dot del Ri del qk qj dot qk dot. Here we summation here j up to j, and here summation is up to k. K is dummy indices, this k equal to 1 to small n. So it is a double summation here, this into this dot plus this mi into this into this, and again this into this. So this into this plus this into this, so 2 into this, and this outside is half factor, so 2 to cancel. So here this summation over I equal to 1 to capital N, and this into this, and last this del t ri vector into del t ri vector, so this whole square is this. So t equal to double summation j equal to 1 to n k equal to 110 alpha jk q j dot qk dot plus summation j equal to 1 to small n beta j qj dot plus gamma. And this first expression is called T2, is called second expression called T1, and last third expression is called T0, say, equation 3, where alpha jk equal to half of summation over I equal to 1 to capital N mi del qj ri vector dot del qk ri vector, and beta j equal to summation I equal to 1 to capital N mi del qj ri vector dot del t ri vector and gamma is this half of summation over mi into del t ri vector square. The expression 3 is the required expression for the kinetic energy T. Next, third part question is show that this the scleroderma system, the kinetic energy is a homogeneous function of generalized velocities. So for scleroderma system, the equation 2 is independent of time t. Then del t ri vector equal to 0 from expression 2. So del t ri vector equal to 0 in this sclerodermic system. Hence beta j, this because del t ri beta j equal to 0, and gamma is also equal to 0 because del t ri is 0. So this actually this is the vector sign. This and so T1 equal to 0 and T0 equals to 0. So kinetic energy T ultimately equals to T2. T2, this T2 is this. So Qj dot Qk dot summation double summation alpha jk. So this T2, in this case T2, in this case means for sclerodermic system is a homogeneous quadratic form of generalized homogeneous because this all square expression in this quadratic form, this qj into qk dot qk dot, so this whole power is 2, so quadratic form, and homogeneous all is power 2, homogeneous form of generalized velocities. Next question 2b. A bead of mass m slides on a smooth uniform circular wire of radius r, which is rotating with a constant angular velocity omega about a fixed vertical diameter. Set up the Lagrangian and find the equation of motion of the bead. This is the figure, no figure, no marks. So you must draw this figure. This is the bead p at any time t with coordinates p, r, theta, phi, polar coordinates, this cylindrical polar coordinates. No, sorry, this is the spherical polar coordinates. Spherical polar coordinates. Here is self-describing. This angle is theta with z-axis, and this angle is phi. The projection of p at this xy plane is this, and this is the origin, and this OP is the r radius vector distance of this. Now we know that kinetic energy T for this system, these beads slides on the smooth uniform wire, circular wire of radius r. And this circular wire is rotating with angular velocity omega. This is the omega. So this is the omega. This is the omega, and set up the Lagrangian and find the equation of motion. Now this mod of v vector, this mod of v vector is v vector is root over vr square plus v theta square plus v phi square, and v vector is a vr into r cap. R cap is the unit vector along the radius vector, radius OP, and v theta is the theta cap. Theta cap is the along this increasing direction of theta. This theta cap unit vector, and v phi cap is the unit vector along the increasing direction of phi cap. So obviously this Vr is equal to r dot and v theta equal to r theta dot and v phi equal to r sin theta phi dot. Here x is r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Hence putting all these t equal to half m bracket r dot square plus r square plus theta dot square plus r square sine square theta phi dot square. This is the expression 1 for kinetic energy T. Here r is constant because this is the fixed radius of this wire. So r is constant, so r dot must be 0, and phi dot is the omega because this phi is this. So rotating with fixed uniform constant angular velocity omega. So phi dot is omega, phi is this angle. So obviously phi dot d phi dt equal to omega, uniform angular velocity. So T becomes this half m r dot r square theta dot square plus r square sine square theta, this omega square. Now potential energy V equals to mgr cos theta because this is the point P and this is the angle theta phi and this r. So from this right angle triangle, and this theta is the perpendicular, this is the hypotenuse, and this is the base. So obviously this r sin theta and this is the r cos theta. So this the height is from this xy plane is the base this from this ground level. So this is the height. This distance is r cos theta. So this is the r cos theta. So Lagrangian L equal to T minus V. So this is equal to T and this is equal to minus V. The expression 2 is Lagrangian. As bit slides on the wire, theta only changes this on this wire, on this wire. So theta only changes here. So take theta as generalized coordinate here. So del theta L, obviously del theta L is this sine square theta. So 2 sine theta into cos theta here. This term is 0 and this cos theta equal to minus sine theta. So this del theta is this. Yes. And del theta dot I, that is the theta dot is only this term. So half m r square into theta dot. So 2 to cancel this del theta. Hence the Lagrangian equation of motion, derivative of del theta dot L minus del theta L equal to 0, and put del theta dot is this and del theta L is this. So after simplification, you can get this theta double dot equal to omega square sine theta cos theta plus g by r square sine theta, and this is the required equation of motion. Next question 2c. A particle of mass m moving in a central orbit under inverse square law, construct the Lagrangian and hence find the equation of motion. Clearly, the force is conservative because this is the central force and inverse square law, and this motion is in a plane, central orbit, motion in a plane. And let r theta be the coordinates of the particle of mass m, and kinetic energy T equal to half m r dot square plus r square theta dot square. This T equal to half m square, V equal to vr square plus v theta square. Here is r dot and v theta is r theta dot. So this and potential energy V, this then F this equal to this the central force, this is the minus del V del R. So this F equal to minus K by R square because this central bond inverse square law is attractive force. So this minus K is positive constant, this minus del V del R. So V equals to integrating infinity to R, from infinity to R. So this K by R square into dr, that's equal to minus K by R. This is the potential energy. Hence the Lagrangian L of this system, T minus V. This is equal to T is this and V is this. So we get this Lagrangian of the system is this. And the equation of motions of the particle here, R and theta are generalized coordinates here. So ddt of del r dot L minus del r L equal to 0, and ddt of del theta dot L minus del theta. This delete this bracket. Now from 1 this we find del r L this equal to this, and del r dot L equal to this, del theta equal to 0 independent of theta, and del theta dot L equal to this. For this term theta dot we get this, and put all these values in equation 2 and 3. We get from the 2 is this, so m r double dot minus m r theta dot square plus k by r square equal to 0, and from the third equation we get this equal to this. So common mr bracket 2r dot theta dot plus r theta double dot equal to 0. Hence, the required equation of motions are mr double dot minus mr theta dot square plus k by r square equal to 0 and r theta double dot plus 2r dot theta dot equal to 0. Next question, 2D. Define cyclic coordinate so that the generalized momentum associated with an cyclic coordinate is a constant of motion for a conservative system, hence so that for the motion of a particle in a central force field of potential Vr, angular momentum is conserved. Cyclic coordinate and the generalized momentum Pi associated with the cyclic coordinate Qi is the constant of motion for the conservative system. Already have discussed in question paper 2021, question 2b for the first and second part. Only here we discuss for the third part. Hence, so that for the motion of particle in central force field of potential here, angular momentum is conserved. Central force F is always directed or away or towards a fixed center, and F varies as Fr. R is the radius vector and this distance from the center. Let this is also always remember that this is a conservative force field, and let a particle of mass m moving in a plane under a central force attracted towards the origin, and force F varies as 1 by r square, and so this is attracted force, so this is equal to minus k by r square. This is equal to minus k by r square. Kinetic energy T equal to half m r dot square plus r square theta dot square. Already we have discussed this. And potential energy V equal to minus this up to infinity. So this is infinity to r f dr. So f equal to minus k by r square, k positive constant. So we get minus k by r. So Lagrangian L equal to T minus V is equal to L minus T minus V is this. Obviously, theta is a coordinate in L. Theta coordinate in L because theta is absent in L. So theta is a cyclic coordinate. Sorry, this is a cyclic coordinate. Cyclic absent this, so theta is absent here. So this is the cyclic coordinate from this in L. So obviously from the second part, corresponding generalized momentum, this p theta, this equal to constant of motion, this corresponding theta. Now p theta, this momentum equal to del del theta dot equal into L, del del theta of L. So del del theta of L is this half m into r square into theta dot. So this mr square theta dot equal to constant. Now mr square theta dot is the angular momentum. Thus when theta is cyclic coordinate and the corresponding angular momentum is conserved. Hence complete this unit 1 and of 2023. Thank you for watching this video.